मैं भी टाइम उसको एक ही दिखाना था, मुझसे बात कर अभी देखो उसको एक दिखाया रिफ्रेश किया तो नीचे के एंगल दिखाया मैंने बोला वाह
मुझे पहले मैथ्स के 2 लेक्चर दिखा रहा था एक ही दिन पे
मैंने
एंड मुझे फिजिक्स दिखा रहा था।
सुना मैंने रिफ्रेश किया रिफ्रेश क्या आता है
मुझे मैथ्स आ ही
नहीं पहले रैंडम नाम आता है हाँ मैं रिफ्रेश करती हूँ तो फिर ये उदय सर का जैसा हाँ उसके बाद वापस से मैंने एक ही क्लास है वापस रिफ्रेश करती हूँ 4 क्लास आ गया मजा
ये जो मैथ्स की एक ही दिन पे 2 लेक्चर दिखा रहा था मतलब फिजिक्स मैथ्स
even for this class no one has uploaded अभ्यास
I did
सगळे झाले
और हाँ एकच राहिले 2 राहिले
2 राहिले
हाँ
तुझा
हाँ माझं 2 का 3 आय थिंक राहिले
आता लवकर कंप्लीट करा आता तुमचे मॉक टेस्ट सुरू होतील आणखी महिन्यानी सो बिफोर दैट यू हैव टू कंप्लीट योर अभ्यास अनीश एग्जाम्स भी देना है एग्जाम्स भी नहीं दिए लास्ट वीक का भी नहीं दिया है बीच में काफी छुट्टियां हो गई है हाँ अभी नाउ festive seasons is over now concentrate on your studies now okay
फिर मैंने रिफ्रेश मारा मुझे मैथ्स दिखाई नहीं रहा था
उनको बोले तो मैंने घर चल गया
नहीं फिर मैंने मैथ्स का क्लियर शॉर्ट सेफ साइड वाला दूसरे बुक के पीछे
एग्जैक्टली
राइट इरिटेटिंग हो जाता है
हाथ से है
टेस्टिंग मैथ्स की
ट्रांसफर का मैंने एक्सप्रेशन मांगा था लेकिन मैंने
ट्रांसफर कर दिया देखते नहीं है
तो मेरा बहुत मैं थी ना मैं ट्रांसफर में
वो भी है मैं भी नहीं थी
एग्जाम चल रहा था मेरा
देखना एक्सरसाइज 7.1 जब सर ने एक्सप्लेनेशन वगैरह करवाया था ना उस टाइम पे थी 7.1 पे मेरे को बुखार आ गया था तो मैं एक वीक के लिए
मेरे सबसे पहले आधा ही हुआ वो बेसिकली
ये तो पूरा नहीं फिर से मैं आई वापस तब 7.2 करा रहे थे सर तो मैंने वो किया फिर जब तक एक्सरसाइज 7.3 आई तब तक मेरे एग्जाम्स चल रहे थे उसके लिए मैं एब्सेंट हो गई
ट्रांसफर
कंट्रोल है चाहे वो रजिस्ट्री किस तरह से
पता नहीं मैं गई थी मेरा टेस्ट दे ऐसा भी क्या है मैथ्स क्यों हुआ मुझे आ रहा है कि नहीं हो गया बोल सकती
मैं सुरानी को मैसेज आ रहा था बताया नहीं लोग से
और क्या है
मूवी है एक ही क्लास है
हाँ अरे वाह चल थैंक गॉड मेरे को सर बाहर बैठे हुए दिखे ना
उसके लिए मैंने कंफ्यूज हो गई भाई मैंने कंफ्यूज हो गई सर तो 10th के लिए आया था
नहीं वो बालका मैम ने कॉल किया था हमने अपना लेक्चर जो एक्चुअली मेरा भी कंफर्म तो अटेंड कर पाऊंगी या नहीं मेरे को नॉट श्योर मैं आपको बताती हूँ हाँ तो फिर मुझे टाइम मिला तो मैं वो कर लॉगिन करते रहे वो दिखा रहा मतलब ये मीटिंग लॉन्च हुआ ही नहीं करके मैंने कहा वाह उनको कॉल लगा तो वो कॉल नहीं उठाते मेरा इतनी बार कॉल कर चुकी हूँ
है ना
और मैं नहीं कर दूंगा
अब तक होने वाला एक्सरसाइज पर एमबीबीएस के लिए अटेंड कर रहे हो
वेटनेस
हाँ अभी ये मैंने देखो नहीं था लास्ट मैंने देखो तो था
तो यहाँ से किया था
अभ्यास क्यों
Why so less?
आगे आ जाओ शायद वहां से ना पानी थोड़ा सा कम आ जाएगा अनिश अभी आ जाओ
आराम से घड़ी कह रहे ना पीछे आराम मिलता कब
और आई कार्ड पहनना है नेक्स्ट टाइम चलो 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 आई कार्ड अच्छा तुमको केला काय कारण देता रे तुम्ही काय खरं आहे प्रकार
क्या कर रहे थे हम लोग लास्ट क्लास
सो वर्क एंड एनर्जी करना है कंप्लीट होगा
ग्रेविटेशन कंप्लीट हो गया लास्ट क्लास में ग्रेविटेशन ही कर रहे थे so we have to start work and energy okay this is chapter number 10 work so when we say work in physics when we talk about work we mean how do we define work in physics so work in physics is defined as work in physics or science is defined as product of force and displacement, right? So if I push this duster, what I'll have to do? Apply a force. That force must produce some displacement. Okay? Then force times displacement, that we call as work. Is defined for work in physics or science is said to be done when a force applied on a body displaces the body in its direction. Okay? Work in physics or science is said to be done when a force applied on a body displaces the body in its direction. So, for example, suppose you have a body and you apply force on the body in this direction, and this body moves in the direction of force by displacement S. So, let's say the force was applied till this displacement. So, then work done is equal to force into displacement. In the direction of force. This is how work is defined. Or W is equal to Fs. Okay. So this is how work is defined. So understood? So if I push this wall, am I doing any work? Why?
Because the object is not moving in other
Exactly.
direction.
Because S is 0. S is 0. That's all. Now there could be another case, like force and displacement may not be in the same direction. Note. When force and displacement are not in the same direction, then W is equal to Fs cos theta. Okay, where where okay, we'll see. First, let us see what is the example. So, generally, when we apply force, the motion is in the direction of force, right? But there may be a situation where force and displacement are in different directions. For example, when you are pulling a trolley bag, a travel bag with a wheel, right? Let's say you have so when you are like so when you are pulling it, the direction of force is in this direction, whereas the displacement is in this direction. Correct? When you are pulling the trolley bag. So now you have some angle between force and displacement. Let's call that angle as theta. Okay. So this is a very common situation that force and displacement are not in the same direction. They're in different directions. Correct. So in this situation, so if you redraw the diagram, you'll get force and displacement like this. So you can make a triangle like this. This is actually force. This is displacement. Okay. So in this case, what we do is we take the component of displacement on force, right? So we project displacement on force like we draw a perpendicular on force. When you draw the perpendicular in the direction of force, okay, then it becomes a right angle triangle. Okay. Understood? This S in the direction of force will be this much. Is that clear? So that's what it is. So let's call this as triangle ABC. Right? Sorry, not this. what is the projection of S on in the direction of force? You have to draw a perpendicular from C to this, like this. Okay. So when you draw a perpendicular of displacement on force, then this thing, so this is that. Let's call this point as B. So AB is projection of AC along F, and AB is S cos theta. Now, what is cos theta? Have you heard about cos sine? No.
It's using
Correct. So let me first make you understand what is what are these trigonometric ratios. Trigonometric ratios. So these are nothing but ratios of sides of a right angle triangle. Imagine you have this triangle, okay, and you know the sides of the right angle triangle have got a specific name. So what is AC?
hypotenuse.
Hypotenuse. BC is
Base.
base. And AB is height or perpendicular. Perpendicular. Okay. Height or perpendicular. Okay. So we define sine theta as, so what is perpendicular? The side opposite to the angle. It is also sometimes called as opposite side. And this is called adjacent. This is next to the angle, okay, adjacent. So you are going to study this in detail in mathematics under the topic trigonometry. But we are, since we are going to use it over here, although it is not in NCERT, in volume it is given. But learn it because it makes learning work simpler. Okay. So sine theta is defined as the ratio of perpendicular upon hypotenuse. Okay. Then cos theta is defined as, these are the definitions of the ratio, base upon hypotenuse, BC upon AC. Okay, you have another one, tan theta. This is defined as perpendicular upon base. Understood? And we have, for different angles, we have values. So let's write down the values. So you will study all this in mathematics. What are the values? So sine 0 is 0, sine 30 is 1 by 2, sine 45 is 1 by root 2, sine 60 is root 3 by 2, sine 90 is 1, and this is again 0. So from 0 to 90, whatever were the values of sine theta, for cos theta it will be opposite. Like for 0 you have to write 1. 30 you have to write root 3 by 2. 45 is same, 1 by 2. Cos 60 is 1 by 2. Cos 90 is 0. And 180 is minus 1. So we'll be using these values more. 0, 90 and 180 for cos. Okay, so these are some of the values. And tan is basically, if you see AB by BC, AB upon BC, this is nothing but AB upon AC into AC upon BC. Correct? Okay. So what is AC upon BC? This is nothing but BC by AC. Upon AC. 1 upon AC upon AC. So what is it? This is nothing but sine by cos. So tan theta is nothing but sine theta by cos theta. So here you just take the ratios of this value. So 1 by 0 will be 0. This will be 1 by root 3. This will be 1. This will be just root 3. 1 by 0 is infinity. And this will be 0. Okay, so don't worry about these things. There is a very easy way to derive these values. In mathematics, you will learn about it. But for now, you know that right angle ratios have a specific name. Ratio of perpendicular upon hypotenuse is called sine theta. And ratio of base upon hypotenuse is called cos theta. And ratio of perpendicular upon base is called tan theta, which is nothing but ratio of sine theta and cos theta. Okay. And these are the values for different angles. So theta, this is called theta. It's a Greek letter theta. Represents angle. Angle between base and hypotenuse. Everybody has written this first column. Erase it. So this becomes the general formula for work done. What if force and displacement are in the same direction? Beta will be 0. What is cos 0? Cos 0 is 1. So cos 0 becomes 1. Matlab, this becomes Fs only. Same like this. So this is a special case of that more general formula, Fs cos theta. Okay, so that is a more complete formula. It covers all situations for work done. So now, in this case, from where this cos theta comes? So, if you look at this situation, this is now perpendicular. You drop the perpendicular. So B is the foot of the perpendicular, dropping from C. Correct? So what is base for this? BC is the base. Base is always adjacent side. Adjacent side. So theta. So what is BC? This is 90, right? Theta and 90. The one which connects theta and 90 is base. So this is now base here. This is now perpendicular. And this is hypotenuse. Correct? So it's opposite. So now we said work done is force into displacement in the direction of force. Correct? So for this, force is F. Force is anyway F. AF wala, wo F. Okay? And what is the displacement? AB. Because the projection of S along F is AB. Right? But what is cos theta for this triangle? Cos theta is equal to AB upon AC. Isn't it? Cos theta for this triangle is ABC. So it's AB upon AC, base upon hypotenuse. So what is AB? Therefore, AB is equal to. And what is AC? Displacement S. So AB is equal to S cos theta. Correct? AB is equal to S cos theta. So we substitute S cos theta here. Therefore, W is equal to F S cos theta. Understood? So it comes work done. This is the general definition. Force into displacement in the direction of force. But here, force and displacement are in separate direction. So you have to take the component of displacement in the direction of force. For that, you have to make use of trigonometric ratios. Is that clear? Is that clear? Because AC ka projection in the direction of force is AB. Clear? How do you get the projection? By dropping a perpendicular in the force direction. Okay. So all these derivations are not in the syllabus. You just have to know this definition. I've just given the justification how it comes. Okay. यहाँ से आ रहा है ये. सब combine हो गया. Gravitation. वो कैसे है? So till here, is everybody okay? So now that we know what is work, let's define its unit. Why do we need unit? To measure work, units of work. So SI unit is joule. We measure work done in terms of joule. So what is 1 joule? So unit of work is joule. 1 joule is equal to 1 Newton into meter. Okay? So unit of work comes from formula for work. 1 joule is equal to 1 Newton into 1 meter, which is 1 Newton meter. Okay? Now SI unit. Now what is CGS unit? It is arc. CGS unit is arc. So arc is equal to, which is equal to, which is, so what is CGS? Newton becomes dyne, and meter becomes centimeter. Okay? The combined name for dyne centimeter is arc. Okay? So what we are calling joule, okay? So therefore, relation between joule and arc. Arc.
Sir, what is the full form of CGS? Sir, I know the meaning but not the
Centimeter, gram, second. Okay, joule. CGS is written in small letters. CGS sometimes, let it be kept. Stands out. 1 joule is equal to 1 Newton meter, which is equal to, what is 1 Newton? kg meter per second square. Newton is unit of force, mass into acceleration. Mass unit is kg and acceleration is meter per second square, and then this meter. Now convert this into CGS. So this will be 1000 gram into 100 centimeter per second square. Again, this is 100 centimeter. So now take the powers of 10. So this is 10 raised to 5 gram centimeter per second square into 10 raised to 2 centimeter. So gram centimeter per second square is nothing but dyne, which is 10 raised to 5 dyne into 10 raised to 2 centimeter. And dyne centimeter is arc. So this is the relationship between, therefore 1 joule is equal to 10 raised to 7 arc. Okay. So in the question, if there is a unit conversion, so what is the relation between Newton and dyne? 1 Newton is 10 raised to 5 dyne. Okay. And 1 joule is 10 raised to 7 arc. Okay. Newton and dyne conversion I have already given you some. Okay. So 1 Newton is 10 raised to 5 dyne.
1 lakh.
Yes. And 1 meter is 100 centimeter. And this is joule to arc conversion. Okay, so it will be useful while solving numericals. So are we good till here? So what kind of quantities work? Scalar or vector?
Direction. We need direction. Sir, displacement is
Force is vector for sure because it has a direction. Displacement also has a direction. But what about work done?
scalar.
It is scalar. So there are two types of products. When you multiply two vector quantities, okay, hear me out. In higher classes you will learn. Whenever there is a multiplication of two vector quantities is involved, the answer could be a scalar or a vector. It depends. Okay. In this case, the product of two vector quantity results into a scalar quantity, which is work. I am doing work, matlab, what is the direction of doing work? You cannot give the direction of work. Okay? So, because work is associated with expense of energy. When I am doing work, basically what happens to my energy? It goes down. Okay? Then I have to eat to gain energy again, to do work again. So energy is a scalar quantity, it doesn't have any direction. And work done is linked to energy consumption. Therefore, work is also a scalar quantity. Okay? So write down. Work is work done is a scalar quantity. Although it involves product of two vector quantities. Force and displacement. So force and displacement are separately vector quantities, but their product is a scalar quantity. Everybody with me till here? Now we'll discuss types of work. So there are three types basically: positive work, negative work, and zero work. Okay, there are three types of work done: positive, negative, and zero work. So how do we differentiate amongst three? So when do we say work is positive? When the force and the displacement is in the same direction, meaning the angle is zero. Okay. For positive work, theta is equal to 0. Therefore, cos theta is equal to 1. That is, F and S are in same direction. Angle always represents direction between the force and displacement. Therefore, W is equal to Fs cos theta is equal to Fs. Okay, this is when we say the work done is positive. What are the examples of positive work done? So pushing a block. Suppose you have a block like this. The force is applied in this direction. The displacement taking place is in the Any other example? So who is doing work? The force or the agency who is applying the force. So if it is a person pushing it ahead, then that person is doing that work. Okay? So work is always done by force. So any other example could be work done by gravity. On a downward on an object or a body in free fall. Free fall. Correct? Suppose you have an object here. What is the gravitational force on this? F equal to, what is the force acting on this? mg, right? And where is it moving? Down. So what is the displacement? Let us say this is the height. So in this case, the displacement is the height, vertical displacement. So force is acting downward and height is also, the displacement is also downward. This is positive. Now let's see what is negative. So for negative work, theta is equal to 180 degree. Therefore cos 180, cos theta is how much? Minus 1. Therefore W is equal to F cos 180 is how much? Fs minus Fs. So we get a negative work done in this case. Right? And Fs cos 180. So this is constant equal. That is F and S are in opposite direction. Like F acting in this direction and displacement in this direction. The angle between displacement and force is 180. Can you think of an example like this?
Tug of war maybe.
Huh?
Tug of war, but it is.
Huh?
Tug of war.
Tug of war. So, how?
This team is losing, that team is.
So the team which is losing is doing negative work.
Yes.
Kind of. What in this situation? I am doing work on this. I did positive work. Somebody did negative work on this. If there was no energy loss due to friction, right, it wouldn't stop. So always forces act in parallel. Action, reaction. Remember? So the reacting force is doing negative work. Okay? So it is not a reacting force actually. Action and reaction work on different bodies. So friction is opposing force. Okay? It's not reacting force. But it is acted by two simultaneous forces. One is the external force applied by me. The other external force is friction on the same body. But it is in the opposite direction. So in the same situation, the frictional force is doing negative work here. Okay? Let's say there is a body moving in the forward direction. Right? So it's moving here. But everywhere, at the contact, the frictional force is acting in this direction. This is displacement. So what is the example? Work done by frictional force is always negative. It's always Can you give an example of gravity doing negative?
So if we watch, we throw an
Yes. Up. Very good. So when you throw the object upward, that time gravity is always acting downward. Okay? But due to negative work of gravity, it will stop at the topmost point and then it will change course. So work done by gravity on upward moving. So like when the body is projected upward, it has to be thrown by at least whatever its weight. Yeah. Because gravity is always acting out downward. So to throw the body up by at least this much force. Let's say it reaches H. So the angle between mg and H is 180. See here also there is some force which is pushing it ahead, but the opposite force, friction, is doing negative work. Okay? This is frictional force. So here this is gravity. And the external force applied on the body has to be at least equal to gravity. So let me not write this equal to any force. So the angle between MG and H, this is 180. Okay, so gravity is doing negative work. We'll discuss the case of zero work in the next class because it has 3 more cases in it in the next class.
हमने पढ़ा इंटीग्रेट का नाम सब